So guys, in a last lecture, we have discussed about homologous series. At the same time, how to represent these formulas and names. Alkanes, alkenes, alkynes we have observed. So here one topic you can observe, that is regarding chains, branches and rings. We have to understand what is meant by chain. Chain is nothing but if you represent a formula in series and in continuation method. I mean, c c, here another c, like that. If you keep on drawing long series, that can be known as chain. And while coming to branches, so if you observe tree, for a tree there will be branches, isn't it? Like that, if you are representing like this, carbon, 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 and for this carbon here another carbon, like this. So if you are representing like this, it will become branches. And while coming to ring, yes, you know meaning of the ring. If you represent here carbon with another carbon bonding here carbon, like that, if you represent, it will become ring. So why we are discussing that chains, branches and rings? Because these hydrocarbons, we are learning about hydrocarbon only, right, at present. These hydrocarbons can be represented in form of chains, can be represented in form of branches, can be represented in form of rings. Let us take one example. Let us take C3H8. What is that C3H8? How to name? In last lecture we have seen C3, meth, eth, prop. This is prop. And relationship between 3 and 8, it is 2n plus 2. 2 3 is 6 plus 2, 8. So it is alkane. So propane. How to represent propane? Like that we can represent C, 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 3 C's, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, as we discussed in our last lecture. Now, do we need to represent C3H8 same like that only? Don't, so for us, is there any possibility to change structures? Means yes, you have possibility. This you can draw like this also. You see carbon, carbon, you can draw another carbon here. Now valence is 1 2 3 4. For this carbon 1 2 3 4. For this carbon 1 2 3 4. Now draw hydrogen, second hydrogen, third, fourth, fifth, sixth, seventh, eighth. Yeah, 3 carbons, 8 hydrogens. Just a structure got changed, but there is no change in its formula, right? So if you are representing in straight, it is known as chain. If you are representing layer by layer, it is known as branch. Of course, we'll see rings also, and that is the meaning of these chains, branches and rings. So these all structures yesterday itself, I mean in last lecture itself, we have seen. And you are familiar here. You see carbon, if you want to represent 4 carbons, for example C4H10, C4H10, 1 2 3 4 carbons in this, and 1 2 3 4 5 6 7 8 9 10. This is chain structure. You see here, first carbon, second carbon, third carbon, fourth carbon, and again for this carbon 1 2 3. For this carbon 1, here hydrogen. For this carbon 1 2 3 carbons you can represent like this. For this carbon 1 2 3 hydrogens you can represent. If you count hydrogens, 1 2 3 4 5 6 7 8 9 10, no change. This structure and this structure got changed, but chemical formula C4H10, C4H10. What is the name of C4H10? C4 means meth, eth, prop, bute. It is bute. Relationship between 4 and 10. 4, 2n plus 2. So alkane, butane. Isn't it? So like that you can represent in form of chains, at the same time branches. Next, rings. Here, if you wanna represent rings, this is possible for alkane only. Alkane. Sometimes, of course, for alkenes also we can draw, but formulas will change. Whenever you are representing in form of ring, we have to call it as cyclo. And I told it is applicable for alkane. So cyclomethane, cycloethane, cyclopropane, cyclobutane, cyclopentane, cyclohexane, etc. But you see, if you want to go with cyclohexane, what you people will do? Hexane. Hexane means CnH2n plus 2. So hex means 6. C6H 6 2 12 plus 2 14. Like that you will draw cyclohexane. No, this is absolutely wrong. If you take C6 and H14, you cannot get cyclo. So for this cyclo, we have a formula, that is CnH2n, that's it. If you see for alkene, same formula you are using now. So for cycloalkanes, we have to use alkene formula CnH2n. Now cyclohexane, what formula you have to go? CnH2n. So if you substitute it, will become C6H6 not C4, sorry, C6H14. No, C6H12. Now you see C6, 1, 2, 3, 4, 5, 6 carbons, and it is hexane. Ane means alkane, saturated, single bond. Between carbons you have to go with all single bonds. Now you see carbons I have mentioned 1, 2, 3, 4, 5, 6, and valency should be satisfied, right? For each carbon, what is the valency? 4. So if you observe this carbon, already one bond, two bonds are there. If you observe this carbon, we have one bond here, another bond here. So 2 done, 3, 4. If you observe this carbon, already 1, 2, remaining 3 and 4. Like that we have to mention, and how many hydrogens you can get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's it, right? So 12 means C6H12. Like that cyclo we have to go. So can you draw the electron dot structure of cyclohexane? Straight chain, branched chain, and cyclic carbon compound. Like these many you can get. You can get straight chains. You can get branched chains. You can get cyclic for hexane. So straight chain means hexane. Branched means hexane. But cyclic means cyclohexane. For that it will change. What will change? Chemical formula will change. So for straight, for chains and branches, no change in formula. Here I will write. For chains and branches, there is no change in formula. But if it is cycloalkane, cycloalkane means cyclomethane, cycloethane, cyclopropane, like that. Formulas will change, that is CnH2n. Because, why? Because you see, in case of chains, consider 6 carbons, 1, 2, 3, 4, 5, 6. This last carbon will get 3 hydrogens. This last carbon will get 3 hydrogens in case of straight chain. But if it is cyclo means what we are doing, guys? We are combining this carbon with this carbon simply to say this bond, both will become only one bond. So instead of three valencies, it will get only two valencies. So that two hydrogens will be lost. That is the concept we have to understand. So we have one important structure, that is C6H6. We can call it as benzene. Benzene in chemical laboratories you can find benzene. Chemical formula is C6H6. How to represent? 1, 2, 3, 4, 5, 6 carbons. And how many hydrogens? 6 only. Okay, let us draw single bonds between all carbons. So now all carbons are bonded and it is in cyclic. But how many hydrogens we have to draw? 6, right? Let us consider for this carbon one hydrogen, for this carbon another hydrogen, for this carbon another hydrogen, for this one, for this one hydrogen, for this one hydrogen. Okay, C6H6 is clear now. But what about the valencies? You see, you take this carbon. For this carbon, how many valencies we have represented? 1, 2, 3. But how many it should have? 4. So what we can do? You can draw one double bond here. So in between carbon, double bonds can be mentioned, right? So 2. Now you see for this carbon, valency 1, 2, 3, 4. Satisfied. For this carbon, 1, 2, 3, 4. Satisfied. For this carbon, 1, 2, 3. Not satisfied. You have to go with 1 double bond. You see, if you draw one double bond here, what will happen? That bond will be applied for this carbon also. So it will become 1, 2, 3, 4, 5. No. So mention here double bond. Now you see for this carbon, valency 1, 2, 3, 4 satisfied. For this carbon, 1, 2, 3, 4 satisfied. For this carbon, 1, 2, 3 not satisfied. Here you cannot draw double bond. Here you can draw double bond. Now like that, it will be satisfied. So you have to draw diagrams like this. You have to see number of carbons. You have to see number of hydrogens. You have to see number of bonds. You have to see valencies also. Next, very important topic, will you be my friend? Here, carbon is very friendly element. Why it is very friendly element? Means carbon will be combining with all other elements. Over, we have discussed now 3 million elements, compounds we can find carbon. Now here, so carbon, it will combine with other elements such as halogens. Halogens means chlorine, bromine, iodine, etc. Oxygen O, nitrogen N, sulfur S. So you see, carbon can combine with chlorine, bromine, iodine, oxygen, nitrogen, sulfur, etc. in hydrocarbon chain. Guys, what is meant by hydrocarbon chain? In a compound, if you find hydrogen and carbons, that's it. That is known as hydrocarbon compound or hydrocarbon chain. One or more hydrogens can be replaced by these elements. For example, if you see this table, for example, we have pentane. Pentane, we have 1, 2, 3, 4, 5 carbons, 1 to 12 hydrogens. Now, here we have hydrogen, right? This hydrogen can be removed. One chlorine can be added. Yes, that is possible. Or you can observe this butane. We have 4 carbons and 10 hydrogens. Consider we have removed 2 hydrogens. So now 2 hydrogens got removed. What is left? 2 bonds are left. Instead of 2 hydrogens, can we draw oxygen here, right? So you can write like this: 1, 2, 3, 4, and 1, 2, 3, 4 valency, 1, 2, 3, 4 valency. For this carbon, 1, 2, 3, 4 valency. For this carbon 1, 2, 3, 4. Here we can draw oxygen and remaining hydrogens we can draw. Yes, we can draw because carbon can combine with any other element. And till now what we have studied about only hydrocarbon compound. You see, in this structure we have only hydrogens and carbons. So in this lecture, additionally what you are going to add is, what you are going to learn is, we can remove one or more hydrogen from hydrocarbon chain. Yes, we can remove one or more hydrogens from hydrocarbon chain, and that hydrogens can be replaced by these elements. What elements can be replaced by? Chlorine, bromine, iodine, oxygen, nitrogen, sulfur, etc., such that valency of carbon remains satisfied. There is no change. You see, if you remove hydrogen and if you add chlorine, 4 valencies only. If you remove 2 hydrogens and add 1 oxygen, if you observe for this last carbon, valency is 1, 2, 3, 4 only, satisfied. There is no change in valency. But there is no change in valency, but there will be some change. What change we will see? In such compounds, the elements replacing hydrogen is referred to heteroatoms. So if you are removing hydrogen and if you are adding some other element like chlorine, bromine, iodine, oxygen, nitrogen, sulfur, these atoms are known as heteroatoms. Names given to that. Heteroatom. What are heteroatoms? If they ask, what can you say? In hydrocarbon chain, if we are removing hydrogens, instead of hydrogen or in place of hydrogen, if you are representing some other element, those elements are referred as heteroatoms. These heteroatoms confer specific property to the compound regardless of the length and nature of the carbon chain. And you see, these heteroatoms confer specific property to the compound. So total property can be changed. First it was only hydrocarbon. After removing one hydrogen, you are adding one chlorine, property will change. If you remove hydrogens and if you add oxygen, property will change. Like that, properties will change, but there is no change in its length. Okay. And if it is changing the property, it is known as functional group. So you are adding chlorine, bromine, iodine, oxygen, something like that. Na? After adding, for the total hydrocarbon chain, there will be change in its property, right? So why it is changing its property? Because of addition of functional groups. We have to say these are heteroatoms, right? If heteroatoms are added, property will change. That is nothing but functional groups. There are many functional groups in carbon and its compounds chapter, but in your 10th class, you are going to learn only 5 functional groups. Let us see those 5 functional groups. This is first, of course, this is first. We can call it as halo functional groups. Halo. In that halo, what we will get? Chlorine, bromine, iodine. 3 we will get halos. Halo. And second functional group name is alcohol functional group. Next, aldehyde functional group, ketone functional group, carboxylic functional group. So I'll teach you how we can get these. Okay. So what is that halo? What is that alcohol? What is that aldehyde? What is that ketone? What is that carboxylic acid? Everything we are going to discuss in this lecture. And you are going to draw these structures. You see, these are hydrocarbon compounds. Chlorine is added here, right? Here bromine, here hydroxide, here double bond O, here double bond O. So like that, you are going to learn how to draw structures of these in this lecture. So what we have discussed, you can represent hydrocarbon chains, hydrocarbon compounds in form of chains, branches and rings. While you are representing in form of chains and branches, there is no change in formula. If you are representing as cyclo, there is slight change in the formula which follows alkene series CnH2n. And we have seen one extra concept, that is hydrocarbon chains. If you observe, you can remove hydrogens and you can add heteroatoms. And if you add heteroatoms, total property will change. And those heteroatoms can be known as functional groups also. This chlorine, we can call it as chlorine functional group, bromine functional group, iodine functional group, oxygen functional group. Like that, you can add functional groups. There are many functional groups, but in your 10th class, you are going to learn 5 functional groups: halo, alcohol, aldehyde, ketone, carboxylic acid, and I'll explain each and everything. Now let us see functional groups and we'll try to learn functional groups. So here I told you functional groups. To draw functional groups, hydrocarbon compounds, what are the things you need? First, you should have an idea regarding alkanes, because functional groups can be added to alkanes, not for alkene alkynes. So you have to know names of alkanes like methane, ethane, propane, butane, pentane, hexane. So 6 formulas you must understand. Methane, C1H2n plus 2, so it is CH4. Ethane, C2H6. Propane, C3H8. Butane, C4H10. Pentane, C5H12. Hexane, C6H14. So that is the first thing you should understand. And what is the second necessary thing? You should be in position to draw structures of alkanes. So in last lecture, we have seen structures of all these alkanes: methane, ethane, propane, butane, pentane, hexane. Okay. Third requirement, functional groups names. Functional group name you have to remember. How many functional groups you are learning in your 10th class? Total 5 functional groups. Total 5 functional groups. What are those? Halo. Second one, alcohol. Third one, aldehyde. Fourth one, ketone. Fifth one, carboxylic acid. You must remember functional group names: halo, alcohol, aldehyde, ketone, carboxylic acid. Next, fourth requirement, suffix or prefix. So if you want to represent halo, what is the method, I mean, do we need to represent in front or back of the name, suffix or prefix? That is regarding naming the compound, guys. Naming the compound. So while you are naming the compound, this suffix and prefix will be used. I'll teach you. Next, formulas for the functional group. Halo means bond Cl, bond Br, bond I. So bond Cl means when hydrogen is removed, Cl can be added. When hydrogen is removed, Br can be added, like that. Well, coming to alcohol, what is the formula? Here in chart I gave, you see, halo, simply to say halogens. Halo functional group, chlorine. So if you are representing Cl, you have to call it as chloro. If you are representing as bond Br, you have to represent as bromo. You have to call that bromo. If you are representing iodine, you have to call it as iodo. Okay. So just try to remember the names enough. Okay, whenever you want to add alcohol functional group, formula is bond OH. So alcohol functional group formula bond, single bond OH, O for oxygen, H for hydrogen. Next, aldehyde. If you wanna add aldehyde functional group, it is bond C will be present at the end of the hydrocarbon compound, last chain. If you are drawing chain, there will be carbon, right? For the carbon, one bond is hydrogen and two bonds will draw oxygen. So this bond is for this carbon. You can leave it, carbon or hydrogen, whatever it may be. But this one bond should be definitely hydrogen, two bonds definitely should be oxygen. So for aldehyde, for carbon, one bond here may be carbon, hydrogen, whatever it may be, but here one should be definitely hydrogen, one bond. Remaining two bonds definitely oxygen. If you are finding this structure, you can call it as aldehyde functional group. Next we have ketone. While representing ketone, you see guys, carbon should stay always middle. Ketone, carbon should stay always middle. One bond here, another bond here. Maybe you see here definitely there should be carbons. Main important, this is so important, every student will get confused here only. So for middle carbon, double bond O should be represented, and this side definitely carbons should stay, because you may get doubt, sir, here in textbook they gave like, see, double bond O, this side and this side we have some gaps, I can fill hydrogen here, right? If you fill hydrogen, what is happening? It is becoming aldehyde, right? One bond is hydrogen, second double bond is oxygen, same, one bond is hydrogen, double bond is oxygen, ketone will become aldehyde. So don't do that mistake. Okay, carbon, this bond, definitely there should be carbon, and middle there should be double bond oxygen. So ketone, carbon, bond, here double bond O, right? And carboxylic acid, for carboxylic acid, C, double bond oxygen, single bond OH, and here there will be another bond. Here it might be carbon or hydrogen, it's your wish. Okay, but double bond oxygen, single bond OH, don't get confused with aldehyde and carboxylic acid. Aldehyde, double bond O, single bond H. But carboxylic acid, guys, this can be represented like that also. Double bond O, single bond OH. Places, it's your wish. It should satisfy valency, that's it. So while coming to carboxylic acid, carbon, this bond, it may combine with a chain. Here, double bond O, single bond OH. So we'll try to draw everything. So first point, you should know alkanes: methane, ethane, propane, butane, pentane, hexane. You should know formulas: CH4, C2H6. You know formula CN, H, 2N plus 2. Draw structures of alkanes. You should be in position to draw. Number 3, there are 5 main functional groups in your 10th class: halo, alcohol, aldehyde, ketone, carboxylic acid. Halo means bond Cl, bond Br, bond I. Alcohol, bond OH. Aldehyde, single bond H and double bond O. Ketone, double bond O and beside single bonds. Carboxylic acid, double bond O, single bond OH. And prefix, suffix names. Now, let us take one example. So remember, this halo will be prefix. So we'll try to hear. This halo, only halo is prefix. What is prefix? Prefix means front. Alcohol, aldehyde, ketone, carboxylic acid will be suffix. Suffix means back or last. What is that last? What is that front? We'll try to understand with 2 to 3 examples. Definitely you'll get an idea. Now we'll try to draw one structure, that is C3H8. So first of all, what is the name of C3H8? C3 means meth, eth, prop, and relationship between 3 and 8 is 2n plus 2. So n, it is propane. Now if I ask you to draw propane, how can you draw? First carbon, second carbon, third carbon. In between carbons, definitely there should be single bond. 1, 2, 3, 4 satisfied. For second carbon, 1, 2 already there, 3, 4 satisfied. For third carbon, 1 is already there, 2, 3, 4. Now let us draw hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens we have drawn. Now this is the accurate hydrocarbon compound, and name of this hydrocarbon compound is propane. Now what extra concept we have learned today? We can remove hydrogen. After removing hydrogen, what you can add? You can add one functional group. Let us take the first one itself, halo. Let us add, bond is already there, add Cl. Cl we have added. Now this is new hydrocarbon compound, right? Now we have to give name for that. What is the name of this compound? Now what I told, while you are naming, we have to follow these 4 steps. First step, identify the number of carbon atoms in the compound. A compound having 3 carbon atoms would have the name propane, right? Identify number of carbons. 1 means meth, 2 means eth, 3 means prop. So name of this hydrocarbon compound is first propane. First we wrote name propane. Okay, next. Second point, in case of a functional group is present. So now we are added functional group na, if it is present, it is indicated in the name of the compound either with prefix or suffix. Okay, so we have to give prefix or suffix. Third point, in the name of functional group is to be given a suffix. Suffix means last. So that we'll see for next example. Now we are going with the prefix, no. So if you are going with the prefix, what we have to do? So this chlorine, if you observe this halo, this if you are observing halogen, it is prefix. Prefix means it should be friend. So what I told you, if it is chlorine, what you have to call? Chloro. And we are adding name, we are adding chlorine, so automatically it will become chloropropane. Simple. Now let us draw this one. 1 2 3 1 2 3 4 1 2 3 4 1 2 3 4. Now if I draw H H H H, here another hydrogen, and at last if I add Br. Now this is not just a hydrocarbon compound. In this hydrocarbon compound we have added functional group. If functional group is present, what functional group is present? Br. Br means what we have to call? Bromo. It should be suffix or prefix? Suffix or prefix? Bromo is prefix. Prefix means friend. So what would be the name of this one? Bromo. Fine, bromo. Next, what is the hydrocarbon compound name? Meth, eth, prop. So bromo propane. Now if you are drawing like this, C I H H H. What name we can give for that? So first of all, this is hydrocarbon compound in which functional group is present. What functional group is present? Iodine. If iodine is present, what to call? Iodo. Next, if iodine is not there, if hydrogen is present, what is the name of this alkane? Methane, isn't it? So it is iodomethane. If you are representing like this, let us assume carbon, carbon, 1 2 3 like this, hydrogen, 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 Br. So it is not compulsory that you have to add at that place. You can add this place also. Now, what is the name of this hydrocarbon first? Meth, eth, two are there. So it is ethane. Is there any functional group? Yes. Bromine is added. If bromine is added, what we have to call? Bromo. It should be front or back? Front. So it will become bromoethane. Right? Like that, we can get bromo, chloro, iodo, you see, bromomethane, bromoethane, bromopropane, bromobutane, bromopentane, bromohexane, chloromethane, chloroethane, chlorobutane, chlorobutane, chloropentane, chlorohexane, iodomethane, iodoethane, iodopropane, iodobutane, iodopentane, iodohexane. Like that, you can add functional group. Now, I'll give 3 examples. Try to draw chloropentane, bromohexane, iodopropane. So you can draw this. So first of all, after observing what we have to do, chloro, just you leave it pentane. Pentane means meth, eth, prop, but, pent. In between carbons, definitely there should be single bond. 1 2 3 4, like that, valency should be satisfied. And everywhere we have to draw hydrogens, except one hydrogen we have to draw. So like that, you can draw all hydrogens. And except here, except hydrogen, what should be added? Chloro. Chloro means Cl you have to add. Same, I think so you can draw for bromohexane, iodopentane. So do it. That's it in this lecture. In next lecture, we'll see remaining functional groups: alcohol, aldehyde, ketone, carboxylic acid. These are all suffix, and we'll see everything and how to name. These 2 points are important for next lecture. We'll discuss regarding these 2 points in our next lecture, and we'll see alcohol, aldehyde, ketone, carboxylic acid functional groups. In this lecture, we have learnt only about halogen, and we have learnt how to name halogens like chloro, meth, eth, prop, butapent, bromo, and iodo.